When you see the word slope, you probably automatically think of a ski slope. So think about like a hill going up and going down maybe. That's kind of what you're going to see on your graphs when we talk about slope. So you'll have a positive slope, except for on your graph, it'll actually look like just a straight line because we're talking about linear equations, okay? Or we've got negative slopes which go down. So positive, negative. But yeah, think about a ski slope. So if you look at, when you're given a graph and you have your line, if you will look at the left side of it, so from the left side of it, this graph is going up, right? From the left side of it, this one's going down.
Oh, okay.
That's what you're looking at, okay?
But the arrows.
Okay. So slope is the same thing, like when we talked about constant of proportionality, constant rate of change, unit rate. It's all really the same thing. So slope is the rate of change between any 2 points on a line, and it's the change in y, which should sound familiar. Change in y over the change in x, okay? And we've talked about that with tables. We've looked at this before. On a graph, it's your vertical change over your horizontal change, which is still your y over your x. Or you'll hear me probably say rise over run. So still vertical, still y over your x change. So on example 1, they give us a table and it says graph the data. So luckily for us, they've already done that. But they've got points at 0, 0, 1 and 8, 2 and 16.
Keeps going up by 4.
3, 24, 4 and 32. Okay, when they give you your table like this, remember the top value is your x value, so that corresponds with that one, your x value, and your y up here, okay?
Would it be going up by 4 though? Because it's 4, 8, 12, 16.
Well, let's see. When you look at your graphs, look at 2 points that are closest to each other, so you have a less likely chance that you have to reduce. So like on this one, I'm going to I'll look at these 2 points. So I'm going to look at 1 and 8, 2 and 16. So we want to find the change in y first. So my change in y, I went from 8 to 16. So what is 16 minus 8? Ooh, that looks bad. 8. So my change in y is 8. And then my change in x, I went from 1 to 2. So yeah, 2 minus 1 is 1.
So 8 over, we've done this before.
So 8 over 1 is my slope. My length is 8. My number is 1. 8 over 1, or just 8. But to make it make sense with your graph, you kind of want it to be over 1. You want it to be over a number so that you can explain it. So for every 8 inches, there is 1 patio block. And yeah, you guys have seen this before when we were just given tables. It's the same thing. 16 minus 8 is 8. 2 minus 1 is 1. And that's your slope. Okay, on the next exercise down here at the bottom. The table shows the number of juices or juice bottles per case. So my x value is the number of cases. The y value is the number of bottles in each case. Okay, so go ahead and plot these points on your graph. Remember, x comes first, so you're going right or left first. Then y is second to make your point. So your first point should be on 1 and 12. The next one's on 2 and 24. Then we've got 3 and 36. And 4 and 48. Okay, so looking at my graph, I want to find the rise over run, or the change in y over the change in x. So I'm going to use these bottom 2 points. So from 12 to 24. So what is that change in y? From 12 to 24. 12. Then our change in x, it went from 1 to 2, so 2 minus 1. 1.
How do you do that?
You're just looking to see how much it changed. It went from 1 to 2.
How to do 2 minus 1?
So 2 minus 1. You're finding the
No
difference.
crap.
Okay, so that means my slope is 12 over 1, or 12. And so what does that represent? So we want to look back at our graph and see what those two values represent. So 12 is my y value, so that's the bottles.
There's 12 juices in one case.
Good. So 12 bottles of juice in one case, or in each case. Okay, then the one at the bottom, a little bit different. They don't give us a table, but they still give us enough information. We can make 2 points and find our slope. So number 2, at 6 a.m., the retention pond had 28 inches of water in it. So at 6 a.m., make your point at 28 there. So then the water receded, which means it's going down. Think about like a receding hairline, it's going away. So that at 10 a.m., there were 16 inches. So at 10 a.m., we want to put a point at 16.
A receding hairline.
Maybe you'll remember that forever. Receding hairline, it means it's going down.
Oh.
So if our graph is going down, I'm going to go ahead and put a negative where my slope is going to go. Because if it's going down, it's a negative slope.
It's a negative.
So it's decreasing, receding. So then we want to figure out how much is it receding by.
You
So
gotta go 28 minus 16, right?
good. My change in y, I went from 28 to 16. So 28 minus 16 is 12. Then our change in x, it went from 6 a.m. to 10 a.m.
But would you have to divide that?
Yes, you want to reduce that down, 12 over 4. So, and make sure you're reading your graph. So, like if you were just counting squares, that would be 4 squares, which is actually okay. But from 28 to 16,
How is it 4?
10 a.m. minus 6 a.m., 4 hours.
6 plus 4 is 10.
Right.
Oh my god.
6 plus 3 is 9.
So we're going to simplify it. So if I've got 12 over 4 as my slope, I really want my slope to be over 1, kind of like when we did unit rate constant proportionality.
There's like no other way to explain 3 over 1.
Good. So we can reduce those both by 4. So that's 3 over 1. So my slope is negative, since it's going down, negative 3 over 1, or negative 3. And that represents, let's look back at our graph, what it means. So it's receding, or I'm just going to say, I'm going to put a down arrow. It's going down 3 inches, because inches is what my y value represented, every hour. Because our x value is going by hours, 10 a.m. to 6 a.m. So it's going down 3 inches every hour. Number 3, the table below shows the number of apples per basket at a farmer's market. Graph the data, then determine the slope of the line. So go ahead and take a second and graph those points on your graph. Okay, so then we've got our points plotted. So our change in y, I'm going to look at the bottom 2 points. And so the bottom 2 points, it went from 10 up to 20. So 20 minus 10. 10. And my x value, I went from 2 over to 4.
2.
So 2. And you can see that on your table also. So 10 over 2, and we want to reduce that down because it's not as small as we can make it. We want it to be over 1 if we can.
5 over 1.
Good. I'm going to divide those both by 2. So 5 over 1 is my slope. And what does that represent?
5 apples per basket.
Good. There are 5 apples in each basket. Each, which is the same as saying 1 basket.
It's going down.
It's going by 4 and it's going down. So it's a negative slope. So I'm gonna go ahead and put a negative sign right there for slope. Okay, so number 4, our y, your x value and your y value. I know the table looks a little bit weird. Mostly you guys will see tables on your test that are vertical, so it won't confuse you as much because the x is on top in your table right now. But if we look at our points, it's going down, so it's going to be negative. But how much does it go down? So it goes from 16, my change in y goes from 16 to 8, right? So 16 minus 8 is 8. And the x, it goes from 0 to 8. Because I said this was going by 4s. So it goes from 0 to 8. So 8 minus 0 is, oh wait, hold on. Is that right?
It's supposed to be 4 over 8.
Oh yeah, I flipped them around. Dadgummit. Hold on. 16 minus 12 is what I meant to put. 16 minus 12, which is 4. And then 8 minus 0 is 8. So sorry.
That's what I had, but
So 4 over 8 can reduce to be what?
2.
They can both be divided by 4, so that's 1 over 2, not 2 over 1. Okay? So my slope is negative 1/2. So it's going down. So the number of cookies, so 1 cup of flour.
I'm done.
1 cup of flour for 2 cookies.
That's not gonna be too big.
Yeah, the graph doesn't make a whole lot of sense. 1 cup of flour for 2 cookies, or if you were gonna do unit rate, you could have 1/2 cup of flour for 1 cookie.